What is up, YouTube? We are here with day 23 of Advent of Code, and it is not Wednesday, 4 p.m. That's because I'm moving house next Wednesday, which means that I've still got day 23, 24, and 25 to do in the next 7 days. So my plan is I'm going to do 23 now, and then I think tomorrow, this might be a terrible idea, but tomorrow I'm going to do 2 back-to-back. So starting at 3 p.m, I'm going to do day 24, and then the usual slot will be our last day 25. So I'll probably do that all as one big 2-hour stream, maybe with a break. And yeah, hopefully the puzzles aren't too hard, because 2 hours of live coding sounds like it could be quite exhausting, but I've not really got much choice. So yeah, that's what I'm going to do. Okay, so oops, I've got my OBS up as well. Because I'm moving house, I've not got 2 monitors anymore. So if anyone does send anything in the chat, I'm much less likely to see it. Apologies. But let's carry on. So here we are with Advent of Code, day 23. So as I always say to those that aren't familiar, Advent of Code hosts 25 challenges every holiday season. And each of those has sort of 2 mini parts to each challenge. So you can see earlier they seem to be easier, and later on they seem to have got way harder. Regrettably, I would have thought I would get a few more, but I normally don't make it past day 8 or so anyway, just because I get tired. But yeah, doing them over 8 months has felt a lot more tolerable. So today we are on Advent of Code day 23, which I've linked in the chat if you are watching it, and also my code solution will be available here, which I've also just linked in the chat. You might have to wait a couple of seconds on the live stream. Right, let's get into it then. I don't give these more than an hour, so I'll probably stop this by like maybe 1:20, 1:30. That's in about 50, 60 minutes. Let's carry on. A group of amphipods notice your family. Oh, wow. A group of amphipods notice your fancy submarine and flag you down. With such an impressive shell, one amphipod says, surely you can help us with a question that has stumped our best scientists. They go on to explain that a group of timid, stubborn amphipods live in a nearby burrow. 4 types of amphipod live there: amber, bronze, copper, and desert. They live in a burrow that consists of a hallway and 4 side rooms. Oh, I don't like this already. The side rooms are initially full of amphipods, and the hallway is initially empty. They give you a diagram of the situation, your puzzle input, including locations of each amphipod, A, B, C, or D, each of which is occupying an otherwise open space, walls, and an open space. The amphipods would like a method to organize every amphipod into side rooms so that each side room contains 1 type of amphipod. Yeah, okay, this looks familiar. So I'll just pop these into the code so I can see them. Actually, let's take that as our starting input. So we'll get a puzzle input. There you go. So that's our puzzle input. So that will change for everybody who does this. You might have the same one as me, since I can't imagine there's that many unique solutions, but that's what we need to support. So in this REPL that I've made, you've got 2 files: an index JavaScript file where you can write JavaScript and run it, and an input.txt where you can paste text. And when you run it, the JavaScript will store that in a variable called inputs. So if you do want to traverse it that way, you can. I think there's probably a better way we could traverse it in this case, but let's see how we do. Anyway, let's start with their example 1, just so that we can track exactly what they're saying should happen, and we'll deal with the puzzle input later. So the amphipods would like a method to organize every amphipod into side rooms so that each side room contains 1 type of amphipod, and the types are sorted A to D going left to right like this. There's sort of like, there's a riddle, what's it called, like fox, rabbit, and cabbage or something. This is like, or it's called leaping, is it called like frogs on logs or something like that? So yeah, this is quite a common one, but it's sort of made more difficult with the addition of multiple entry points, multiple exit points, and an actual hallway that they can navigate. So we'll have to take some sort of leeway there, I suppose. Anyway, amphipods can move up, down, left, or right, so long as they're moving into an unoccupied open space. Each type of amphipod requires a different amount of energy to move one step. Amber amphipods require 1 ng, geez. Bronze amphipods require 10. Copper require 100, and desert ones require 100. So this would be a useful comment, so I didn't describe that before, but in JavaScript we can write a comment with 2 slashes. So we can just write some plain English now. So I'll just write, maybe I'll write this 10. Keep it simple. Cool. The amphipods would like you to find a way to organize the amphipods that requires the least total energy. Gosh. However, because they are timid and stubborn, the amphipods have some extra rules. Amphipods will never stop on the space immediately outside any room. Right, so they can never block. This is so hard. Okay, amphipods will never move from the hallway into a room unless that room is their destination room and contains no amphipods. I might just forego all of these crazy rules because this is hard. It can stay in that room until it leaves the room, for example. Starting room, it's not. Yeah. Once an amphipod stops moving in the hallway, it will stay in that spot until it can move into a room. In the above example, the amphipods can be organized using a minimum of 12,521 energy. One way to do this is shown below. So bronze comes out, moves into the hallway, taking 4 steps, and waits. The copper amphipod, not in its side room, moves there. Okay. Desert amphipod moves out of the way, taking 3 steps using 3000 energy, and then the bronze amphipod takes its place. Wow. This is really, I mean, a difficult starting point, even more difficult with the rules perhaps, though at least that sort of restricts the potential solutions we have. But figuring out the least energy required is also its own problem. I wonder if that's something we can, can we use like what's called a heuristic, where instead of trying to do something clever and find all possible combinations, because really we could draw a tree out of, B could move up here, B could move left, B could move right. There's loads of different solutions to this. Finding along the least energy is not going to be easy. I would hope that all we really need to do there is minimize the movements made by the larger ones. So if we always prioritize the movement of A, for example, is this the starting one there? Is that what they did? So you look on like the top of each stack and B is the highest, well, the lowest energy to move. So it tries to sort itself out. No, because then it pops out D. Why does it do that? I guess the difference is maybe it has to be D next. So what does it go? B. Yeah, so at this point, we've got B out. The only possible moves are C, C, and D, but this C is in the correct position. This D is not in the correct position, so maybe with the priority of C needing to move first, C should move. Then here, D's in the correct place, but A isn't. D is not in the correct place here, and it's also blocking B. So D must move. I feel like this D has to get... How do we get that A out? That D needs to move all the way over there, I think. So that D gets out, it starts moving. This reveals a path for B. So now B can move. Cool, and then that D, oh interesting, because the A is cheaper, so the D can come out, moves the left because it's already blocked out. I don't know how I'm going to do this at all. Then A can come out, and then that minimizes our moves for D. I think I might just see if I can do any solution rather than the best solution, because this feels like an absolute nightmare. Right, we've got our inputs. So really what we need now is some sort of data structure. I guess like the two options we have, right, are either do we translate this object into something else? So let me find. So we've got this. We could break this down into a grid, just a 2x2 grid. Oops. We could break this down into a 2x2 grid along the grid lines like this, and then actually code the ability for each of these individual amphipods. Basically, as an object, this has the ability to go up, down, left, right. It also has to have the ability to check if that spot is free, because they can't move. You can't move right, for example, because there's a wall there. Can't move left because there's a wall, and can't move down because it's occupied. So the only move for B is up. Same for C, the only one is up. Same for B, the only one is up. Same for D, the only one is up. And then at that point, we need to do something to test what's the best move. Which I don't know at this point. Did they say... Let's not go with best move, let's go with any move for now. So there they popped out that middle B. Why? So this B was the preferred move. But it would have to move all the way to here, wouldn't it? Yeah. So I guess the next preferred move is getting this C down there. And that's blocked by the B. And now the B is here. To get the D out, this is really hard. I don't understand. Anyway, let's do it like that so maybe we can control the moves. Yeah. Or the alternative is there a better way than this 2D array? So should we perhaps instead store this as sort of, you know, just as a hallway object, and then this as their own separate objects as well? So these are just these are effectively, well, they're not queues. I would say they're queues, but the difference is if we stored, for example, this one, we'd store it as D, and then we would normally we'd say, with the queue we'd say first in, first out, right? So the D is in the first position, so the D gets out. But when we pop that queue, normally our queue would just become A, but that's not really the case here. It's actually an empty space and an A. And then we need to code the ability for that A to move into that space, leaving behind a space still that can be used, or filled even. So we could do it this way. So we could have a hallway, H, and we could have, I don't know what these are called, burrows, are they? So we have burrow, I guess we have burrow A, and then we can use those as sort of so now we can break it down into just these arrays, and each one has an entry point. And then we just need to start by reading those things in. I have no idea how we're going to write any logic around that other than the ability to sort of push, but not in the traditional sense, the ability to move within and also the other way round, and the ability to enter. And then up here we just need the ability to go left and right. So that looks like it makes a bit more sense and might be sort of trackable. So let's start by defining a hallway. So const hallway is going to be, how long is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then I'm going to set const BA equals, let's just leave them all as zeros for now. And this is going to be just an easier way of representing everything in something that isn't just this input shape. Otherwise, that's all we've got to start with, and that's all we've got to go with. Let's get all these rules out the way for now, because we're not going to come to those for ages. Like valid moves, we've not got any notion of a valid move. Right, so since the grid is always the same size for now, we can sort of cut some corners here. So BA is inputs 0, this would be 0, 1, 2, 0, 1, 2, 3. That should be B now. Nope. Have I done that backwards? Inputs. Why did I write 0? 0, 1, 2. 3. So you can just see I'm using the REPL on the right hand side, and that will sort of evaluate things on the fly so I can make sure I'm getting what I think I'm getting. So this should be 3. Inputs 2, 3. I'm just going to paste that over the other ones because now I only need to change one of the things each time. Oh, no I don't. Oh. BA. Now I need inputs. To 5. Yep, so this becomes 5. This becomes 7. This becomes 9. BA, BB, BC, BD. That looks good. Does it match up? CD, BC, BA, DA, sorry. Right. Now, I guess let's just try and replicate this move set, right? And that will give us everything we need to be able to do. So the first one is a hallway move. So let's write a function called pop q const pop equals q. I can pass that a variable, and let's just do console.log q 0. So now I should be able to call pop on BA, and I should get B. Cool, so that worked. Pop BA. Oh. Why is it giving me 2 console logs? Ah, because I'm not returning anything. Let's do that. Pop BA. Oh. BA. Cool, there's our B. Now the issue is BA still is holding B, so I actually need to do is replace the first item in that list with nothing, because that's what is always going to happen when we're popping. So now we need to say Q0 equals 0. That should cover us. So now BA has been popped. If I pop BA, there's still nothing there. That makes sense. What doesn't make sense is that our hallway is now empty. So when we pop something, we need to be popping out into the correct position, which means that we need to also store what that correct position is alongside our queue. So our choices here are either to convert this into an object, storing both the queue and its exit or entry point, or I just store them all separately, or I hide it in the array somewhere. So I think of those, the one that makes the most sense is probably, sadly, putting them in a big object. So I'm going to do queue that, and I guess I'll call it exit is 1, 2, 3. That should cover me. So I just need to do that for all three of them. B, 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 C, B. You know what? It gets worse because I do actually need to know which one ends up in which one as well. That's kind of convenient that, well, it's not convenient that the exit is actually the position of each input. That might be helpful later. Normally the second part of each of these really punishes you for whatever you do in the first part. So I'm expecting maybe part 2 is infinite burrows, infinite hallway length or something like that to make it even worse. Okay, so now we've got that, we need to put in the hallway position, hallway, calling them queue is pretty rubbish now as well. Queue, am I calling, this is a queue with an exit, so this is the, I don't know, occupants. Right, so console.log queue.occupants, queue.occupants 0 is now 0, hallway queue dot exit equals, I should have stored this later, so I need to do that overwrite last. And also I can only do it if it's not occupied, so to do if not occupied, otherwise we can't make the move. So hallway now has a B in position 3, which is wrong. It is the third position. That's the discrepancy there between the barrier and no barrier. So that means this just needs to be a 2, this needs to be a 4, this needs to be a 6, this needs to be an 8. So hallway now, that's better. Really, I'd like to put it on that picture. Maybe I will. Let's do that. To do print board. Right, I need to check if it's occupied, but I'm not going to do that yet. Let's write a print function. So const print board equals inputs. Oops. Inputs dot for each row console.log row. So now I should be able to print the board whenever I want. we go. What I actually want to do is in the second one of those, change the row, which I could safely do in here, because I'm only reading in my inputs once at the start, so every time I print, I could just overwrite the inputs. So what I'm going to do is I'm going to say inputs, actually let's do it over here, inputs 1 should give us that hallway list. Then I should be able to overwrite that with, if I do inputs 1, I think that'll only overwrite one of them. I don't know how to overwrite all of them. Maybe I could do inputs 1 equals a quote plus something plus a quote, like that, and then all I need to do is put my hallway in here joined up. So hallway.join, let's join on nothing, and there we go. So now if I do inputs, that's worked, but I haven't updated my queues, so I need to do the same thing for the queues. So I need to do like the opposite of what I've done here, which kind of is extra annoying. I could just show the hallway, but that wouldn't be very fun. So let's do set hallway inputs 1 equals plus hallway.join and then I need to do the other way around, so I need this but backwards, so I need like inputs, gross, let's get all these, and then let's do this, 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 and then I just need to go over all my queues and overwrite them as well. Oh no, I just overwrite my hallways code. So at the end of the day, I've basically chosen to maintain both data structures just because the visual benefits of the 2D array are also useful, especially if we don't think we're going to finish this in time. Equals ba.occupants 0. And that we can pop this all the way down. No, I can't. Let's do it manually. Right, BA occupants 1. B, BC, oops, BC, BD, BD. That should give me what I want. So inputs has been overwritten with nothing, but I popped, so that's not good. Why has that not changed? Has hallway changed? Yes, but inputs hasn't, because it's only in my print board function. So I only do it when I would need to do it, and that takes inputs. Still got a B there. Why is that? BA.occupants is a 0 and an A, so why has that not happened? What is BA occupants? Inputs 2, 3 should be B. Inputs 2, 3 equals BA.occupants 0 is a 0. It's not updating it. So have I got perhaps a local copy of inputs here when I shouldn't. If I do that, that should modify the global one. No? Same thing? We have popped BA for sure. I haven't printed the board yet, so that's fine. That shouldn't have actually updated. I just need to call it like that now. Ah! Why has nothing changed? That's very annoying. Oops. Okay, so the hallway is changing correctly, which is nice. But maybe, let's see if I replace this with a 0. Does it update? Print board. No. Interesting. Oops. Let's do a print board there. So this isn't working. Why isn't this working? Inputs 2, 3 equals 0. Inputs doesn't work. Why? Is it because I'm taking a new variable when I do it there, whereas what I actually need to do is replace them in the string, which is why the hallway one is working. Replace car in string. I think that's the issue. If it was actually broken down, into a 2D array, then I could do this. Easy peasy. But it's not. So should it be? So I could do inputs dot for each row. Actually, let's do a map. This is a lot of. So let's map the row to the row split on anything. Now my inputs are the same thing because I have run print board. Why are they that? Because I haven't updated it. Inputs equals inputs.map. Oh, surprisingly that doesn't break anything. Does print board still behave? No, because I can't split it again. That's okay. So after that, I just need to join it back together. No, I can't. Can I? Dot join. So that should reverse it. Yes! Wow, okay. So all that just to update the inputs and outputs. That was because this was basically taking a variable. So if I had something like cat and I do cat 0, I'll get the letter C. But that is its own it's a variable in its own right. So if I say equals D, that variable still equals D, but in the original cat it hasn't changed. So what I really need to do is this, x equals cat, x0 equals D, x cat hasn't changed, x0 C hasn't changed, but that variable we got out has changed, even though we can't access it anymore because we didn't store it anywhere. Right, so now I can print my board after each move, and I can successfully pop the queue. We can't test if not occupied yet, but we can move up the queue, I suppose. We probably need a function for moving up. Do we ever want to move up and down? It's probably worth writing. So we're probably going to need a move up in queue, move down in queue, and exit and enter, but I guess exit and enter are just moving up and down through that boundary. So this is more referring to, for example, we have now A needs to move to position 1, or another one might need to move down properly. So B, it's not really what B needs to do. B is about to enter. B needs to enter a burrow. Let's say C needs to exit a burrow, and we don't really have an example of moving down in a queue yet, but this is from position 1 to position 2 when we do see that. Right, I'm just going to go to the toilet quickly and get some water. I'll just be right back to the screen, 1 sec. Hello, thank you. Right. I hate this one so much. We've only got like 15 minutes left. But I guess I feel like it's been useful just to actually break this down into some useful objects. Anyway, let's see if we can code moving someone up in a queue. Actually, do we need to? Should we just follow what they did? So their next move was to go right one, which we also don't have. So this is sort of to do queue movement, but we also need a to do hallway movement. And I think there's something bigger here. Really, we could have like an object representing each amphiod, and then those hold the ability to move, and that ability to move changes depending on what their current position is. So maybe we can mark hallway spaces with a H, for example. I'm going to do that now, actually, because that's a good idea. Oh, did that only work because I left a 0 here? I hope not. Please. Thank God. Okay. I'm going to mark them with a queue position, just to separate queues and hallways, because it does matter. And let's replace all these zeros with H's, because then I can say, you know, if this is a H or if this is a Q, I can do different things. Okay. Now, queue movement, I'm not going to bother with yet, because I'm just going to work through the scenario they've given me. So we have left, left, if you can, and right, move right if you can. These should be fairly easy. So let's do const left equals, that needs to take x. Do I need to know where they are? Yes, because I need to check to their right. So left needs to be the position of this amphiod, which again, if we had objects, we could say, you know, this dot position, we could store all this stuff. At the moment, I don't know how we actually have that, how we refer to just this one. We kind of have to point and say, so we're going to have to say, yeah, I want that one to move, which is a bit annoying. So that would be inputs 1, 3. So let's say yx, const left, if inputs yx minus 1 is equals h for hallway, then I need to move left, clear right. Otherwise I need to do nothing, so I can just leave it. So move left needs to be, this now needs to be whatever was in inputs yx. This does mean that we could try and move hallway spaces, right? So really we should only do this if it's a B, C, or D. So let's check that as well. I'll do const valid amps. It has to be an A, a B, a C, D. And then I can say if inputs yx contains, no, check if cats in array JavaScript includes. Contains must be Python, apologies. And we want this the other way around. So that includes, if valid amp includes that. Oh. Let's just do a little test. It's found. And then let's try calling left on something. Let's do it along the bottom with our pop. So left 3, 1. 3. Oh, that is right. Left 3, 1, undefined. But if I print the board, didn't move. It's the same issue again, is it? Because I'm updating the string instead of splitting it first. I can't just do this every time. This is crazy. Maybe it should just be an array. Okay, well, let's take these bits for now. So if it's found, it should be logging it's found anyway. I got them backwards. This is where they should be x, y. Why didn't that do anything? Why isn't that doing anything? Inputs 1, 3. If valid amp includes inputs, it should be logging it's found. B is definitely there. Yeah, it's true. Let's just console.log these for a quick sanity check. Console.log inputs x, y. What is that? Is that what? Why is it logging that? That's that like third. That's this row. 1, 2, 3. 0, 1, 2, 3. What? Is it going to do that every time I do? Is that part of the print board now? No, okay. Weird. So that's my two logs of valid amp and the inputs x, y because it's not, because it should be this. Ah, and it should be this. Because it's not an array. Now, it's getting a dot. How is it getting a dot? Inputs x, y is a dot. There's no dot in there. Because I haven't printed the board. No, why is there a dot? Inputs at this point has not been updated yet. It has been. What on earth? Where is it getting the dot from then? X, Y, 3, 1. Have I swapped them around again? No. Okay, good. So I'm guessing this left is running before the print board, so the board hasn't actually been updated. So I need to remember to print the board between every run. There's the B. B is found. So it is a valid move. Then now left should... No, this is not working for the same reason. Right, we were talking about this before. I have to do this row split thing every time I want to make a move, sadly. Which isn't ideal, but that's the mistake I've made so far. So we've got our row split and join. We've got our move left here. Then we need to add our move right. This is wrong again, right? I've just completely got all of the syntax wrong. So this needs to be the same. Whoa. How have I done this so... Right, I'm going to stop doing that because that's clearly not working. This needs to be Y, this needs to be X. Moving left should now be working if I print the board again. It doesn't. Inputs YX. Has anything swapped? Doesn't look like it. Maybe I've accidentally moved to H though. Let's pop this in there. It's definitely getting the B. It's just not doing anything with it. Inputs Y. Zero, 1, 2, 3. It's not going in there at all. So this is failing. So let's console log that. Is it a H? Test 2 is a nothing. Because it should be the other way around. It should be 1 and 2. Huh? No, it shouldn't. How did that happen? 3, 1. Yes, that should be X. Sorry. Whenever I access them, it should be X and Y. This should be X and Y. This should be X and Y. I'm really... Well, actually I have no idea now. Let's see if it works anyway. So test is H, test is H. It hasn't moved, but I haven't updated the board. So hopefully a run of print board. Let's put a print board in there just so it's easy to see, though it hasn't changed at all. Right, so test 2 I'm happy with. Test 3, so this should be updated with that. Should be, but it isn't. Then the board is not updated either. So what did I have to do? Let's add in that this should now. Ah, why does it do that? That also needs to be a H now, which also isn't updating. But I'm pretty sure the positions are correct since we're getting H's and B's. So that's our clear right. And then inputs isn't being updated for some reason here. Let's check actually in inputs. No. Inputs 3, 1, 2 equals 0. Yeah, same issue. Though I thought we fixed this before by splitting the rows. So what did I do differently there? If I leave it like this, we should see it all split. Rows.split is not a function. That's weird. Inputs equal inputs.map row.split inputs 1 inputs 2, it's a H, it's a B, equals inputs 1 3 inputs equals inputs dot map row dot join okay, which makes me think now maybe this if statement isn't correct. It's a H. Does it go in here? Oh, that's not nice. So why isn't that updating? The splitting is happening, the joining is happening. The logging isn't happening, but that shouldn't matter. Really weird. Anyway, that's been about... Oh no, let's give it a second. So weird that this one doesn't work though. I don't know, inputs looks like it's spelled correctly. It seemed to work on this right hand side, so what's different? Got some console logs, but they seem to be fine. That is a H, which means that, and we know it's going into the array anyway. So what is this about? Inputs x equals... I mean, regardless, this should be working. And we know that it is inputs 1 3 is getting that B, so that should be, that alone should be working. That should be clearing it out every time. Nope. Not sure. Well, that's not been very productive, but I'll leave it like that for now since it's been about an hour, and I do have to do 2 of these tomorrow anyway. Yeah, but hope you enjoyed that. Wow, that felt very chaotic and we barely got done. I have no idea what I'm supposed to do for the rest of this because I haven't even written the ability to move. I feel like I probably could have done it quicker if I just tried to do it manually. If I put this here. Anyway, yeah, let's leave it there. Bye bye, see you tomorrow.